Hey guys, welcome back to the continuation of carboxylic acids. We have started I believe, the second last, yes, the second last homologous series of organic chemistry of your syllabus that is called carboxylic acids or carboxylic acids. Guys, I would like to bring your attention to one more thing again, that all the carboxylic acids are also called as organic acids. Okay, carboxylic acids are called as organic acids, and inorganic acids are also called as mineral acids. So mineral acids are also called as inorganic acids. All right, okay, now I am telling you one more point, that examples of mineral acids, many of you have already that examples in their mind, but I'm just giving you a reminder. It is H2SO4, it is H3PO4, etc. So all of these are the examples of mineral acids. Whereas when we are talking about carboxylic acids, one should know this thing, that this part is compulsory in them. Okay, so if there is one carboxylic acid, it is simply called as oic, or if it is two times, then it is called as dioic. Dioic. Okay, so we are going to write down the names of this so that we may have a practice. Okay. So for example, this is a carboxylic acid and it has how many carbon atoms? One, two, three, and four. Okay. So how many carbon atoms are there in total? Four. It will be called as bute. So it is called as butane, butane dash one oic acid. Okay. Or it is called as butanoic acid. Butanoic acid. Okay, why it is so? Butanoic means four carbon atom having one carboxylic group attached with that. Butane mean four carbon atoms at position number one. At position number one, oic. I mean to say at position number one, C11 OOH is there. Okay, remember this thing, that carbon of carboxylic group will be counted as carbon number one. Okay, and then you shift the counting on the other side, then to move the counting on the other side. Okay, now let's see, there is another example for the same number of carbon atoms. So it is this and this. Okay, you guys can see this thing, that this is a four carbon atom chain. Again, there are two carboxylic groups, one carbon atom and the carbon number four, both of them have carboxylic group. Okay, so what will be the name for this? Here obviously CH2, here obviously CH2. Similarly, whenever you are writing in the exam, you should know this thing, that all of the hydrogens should be completed. Guys, one more thing which I am receiving in the different types of the comments, that H3C and CH3 are the same thing. But the basic key point is this, that carbon has to make four covalent bonds always. Okay, so when we are writing like this here, H3C, it means that carbon has made one bond here, and now it is going to fulfill its remaining valency with these three bonds with three different hydrogen atoms. Okay, now what will be the name for this compound? Here it is called as 1 comma 4, or you may mention this bute thing, bute dash 1 comma 4 dash dioic acid, the example which I have given you on the previous page, the point about which I was mentioning on the previous page. Okay, so at position number 1 and at position number 4 there is a carboxylic group, and that is called as dioic. Okay, is that clear right now? So this is how we are going to work for this type of acids. Okay, I am going to take you to the next page with a few more examples for naming. Remember this thing, guys. I'm bringing your attention again and again on the same point. You have to call this carbon atom as the major carbon. You have to consider this carbon. You have to count this carbon, the carbon of the carboxylic acid. Okay. Many times, this is a frequent mistake which I am observing in many of the papers. And what is that mistake? That students are, for example, if it is said that write down the formula of the pentanoic acid. Okay, now student get an idea. Oh, pent means five carbons. Okay, DK. Okay, done. Then how to write this thing? One, two, three, four, five, and then carboxyl group. Okay, okay, perfect, done. But this will be considered as wrong. Why it is so? Because this carbon is number one, this is number two, number three, number four, number five, number six. OMG. So I was just counting five carbon atom, but this is now six. How it is? Remember this thing that carbon of carboxyl group will be counted. Carbon of carboxyl group will be counted. Okay, so this is an important point which you need to keep in your mind. Okay, and if, for example, I'm saying you about that pentanoic acid, then what will be the formula? I'm just giving you a hint again and again. Remember this thing, you should write carboxyl group first. So carbon of carboxyl group will be written automatically. So one carbon is there, already one carbon is there. And now according to the pentanoic thingy, we have to write five carbon atoms. So one is written and I have to write four more. So it is like this. Okay, so I am just fulfilling the demand of the hydrogen atom. So it is like that. And the carbon of the carboxyl group has already made three bonds. So it is now going to make one bond, which is this. Okay, so this is how we are going to write down the names of the carboxylic acids. This is the way that you have to count the number of the carbon atoms. This is the way that you are not going to forget the carbon of the carboxyl group. So this is really, really very important. Now, if I am talking about the reactions of the carboxylic acids. Okay, guys, before moving towards the chemical properties of the carboxylic acids, I would like to bring your attention towards the physical properties of the carboxylic acids. Okay, so I'm writing here physical properties of carboxylic acids. Okay, so number one thing is this, that lower members means having lesser number of carbon atoms. Lower members are soluble in water. Lower members are soluble in water, releasing hydrogen ions. Okay, then number 2 point is this, due to availability availability of mobile ions in the solution in the solution carboxylic acids can conduct electricity. So this is an important point to be noted. And then if we are talking about number 3, lower members have lower members, or you may say boiling point is gradually increasing. This is just the physical property which we have studied earlier as well. Boiling point is gradually increasing, is gradually increasing. Okay. Okay, guys, I would like to bring your attention to the ionization of carboxylic acids before starting the chemical properties. Okay, so let me inform you that organic acids, which are also called as the carboxylic acids, are considered as weaker acids. We have discussed this thing when I was teaching you the chapter of acid, bases, and salts. Okay, so what is the definition of a weaker acid? It is partially releasing hydrogen ions in the water in the solution. Partially. The word of partially is important. Okay, and in case of stronger acids, you will say fully ionized to give hydrogen ions. Here you will say partially ionized to give hydrogen ions. So it is not very much willing to give its hydrogen ion. Okay, partially ionized to give hydrogen ions. Okay, guys, look at here right now. What is the meaning of partially ionizing? And sometimes examiner is asking that you need to write down the equation to prove your thingy, that this is stronger and this is weaker, and what is the meaning of fully and what is the meaning of partially. Okay, so for example, if it is HCl, which is an inorganic acid. Okay, which is an inorganic acid, so I'm just converting it into its ions. Okay, so you can see it is going to make you this and this as well. You can check the arrow perfectly. Okay, if I'm writing this acid CH3, here I'm writing C double bond OOH. Deliberately I'm always writing this bonding so that you people may have a more and more idea that how to write this bonding. Okay, so this is what is called as the two carbon carboxylic acid, which is called as a ethanoic acid. So look at the arrows very clearly. So what will be the name here? It will be CH3, C double bond O, and then O minus plus H plus. So you can see this thing that here this is the negatively charged ion. And one important thing which you should not miss is this. Okay, so carboxylic groups are ionizing, carboxylic acids are ionizing with the help of a reversible arrow, because they are not that much willing to release their hydrogen ions. That's why you have to write down this type of an arrow. Okay, but in case of the stronger acids, the arrow will be definitely a different type, which I am just marking here clearly. Okay, so a single-sided arrow for the stronger acids, whereas the reversible arrow for the weaker acids. This is how it is. This is the way we are going to write down the organic acids, and this is the way we are going to write down the ionization. On the next page, I will write down the ionization equations of first 4 5 acids, so that you people may have a better idea about this. Okay, let's move on to this page. Let's write this thing. So this is HC double bond O, OH. O, how many carbon are there? One carbon. So the compound will be called as methanoic acid. So it is HC double bond O minus plus H plus 1. Okay. So methanoic acid, and that is called as methanoate ion. And this is now CH3, C double bond OH. Okay. So this is now H is over there, and and the reversible arrow, it is just C H H, and the C thing will be remain there. This O, C double one O, and this O will be remain there. Don't forget that there is a negative charge, very clearly a negative charge over there. Okay, so please remember this thing. Okay, now I am going to write this again. This H plus. Okay, guys, if you will forget these charges, then things will be in a problem. Okay, so here it is a 3 carbon atom chain. Sorry, Vijay. So this is now O and H, and this is H2 here, and this is H and H here, H here. Okay, so this is a reversible arrow. Again, it is HCCH. This thing remain there. All the bonds will be remain there except this O, which is making a negative charge now, and this is this. Okay, guys, I would like to tell you the names of all these. Okay, so what is the name of the first one? It is called as methanoic acid. Methanoic acid, and the ion is methanoate ion. Methanoate ion, and this is ethanoic acid. Ethanoic acid, and this is called as ethanoate ion. Okay, so this is called as propanoic acid. Propanoic acid, and this is called as propanoate. Propanoate ion. All right, so these are the names which are associated with these acids ionization. If you people will get the idea about the ionizations, and thing can become improved, then the many issues can be resolved. Okay, in one paper, examiner is asking prove the strength of the acids. Okay, or you he's saying that there is one beaker in which 1 mole per decimeter cube, 1 mole per decimeter cube HCl is taken, and in the other beaker it is 1 mole per decimeter cube of ethanoic acid is taken. Okay, so which acid is stronger, and prove your argument with an experiment. Okay, so guys, we already know this thing by studying the chapter of acid, bases, and salts, that whenever a metal carbonate is reacting with an acid, it is going to release carbon dioxide gas. Okay, and you know this thing that the Milky One experiment. All right. Okay, so what was that Milky One experiment? That when we are going to pass carbon dioxide gas through lime water, it is turning lime water milky. Okay, so that was the identification test for carbon dioxide. Okay, so here I am telling you that, for example, in this case, you can see this thing that more volume of carbon dioxide will be released in a shorter interval of time in case of HCl. So it is what it is. So it is called as a gas syringe. So you may say this thing that, for example, with HCl 1 mole per decimeter cube when CaCO3 is taken, like for example 50 grams of CaCO3 is taken and reacted separately with HCl with 50 centimeter cube of HCl on one side and 50 centimeter cube of ethanoic acid on the other side, and then you can say this thing that this is the reaction setup which is happening here, and then you are going to combine this with this. Okay, so this is there should be a bung over there. This diagram is really really very important, and I will draw this diagram when I will teach you, when I will explain you the past papers shortly, inshallah. So right now I'm just telling you that this is a conical flask in which the reaction is happening. Okay, so I'm just writing reaction mixture is there, and as a result of this reaction we already know this thing that carbon dioxide gas is going to release. And when we are talking about the strength, we can say this thing that HCl is a stronger acid. That's why it is releasing more volume of hydrogen gas in a shorter interval of time. Okay, more volume of carbon dioxide gas in a shorter interval of time. So carbon dioxide is a gas which is being produced in this reaction, and you may say this thing that more volume is produced in a shorter interval of time. So you have to give the supposed values as well. For example, you may say this thing that in you may say that, for example, in 3 minutes, which is equal to 180 seconds, you may say this thing that for the HCl, the carbon dioxide release is 56 centimeter cube, and for the CH3COOH same time, and the carbon dioxide released is, let's see, 21 centimeter cube. So it is just telling you that both of them have released carbon dioxide, no doubt, but the carbon dioxide released volume is greater in case of HCl, whereas it is lesser in case of CH3COOH. So this is how we are going to work on this. Okay, next point can be one other option to measure the speed of a reaction, to measure the strength of the acid, is the reaction with the metal as well. So we know this thing that whenever a reaction is happening between a metal and an acid, it is going to release another gas, and that is called as hydrogen gas. Okay. Now, what was the test for identification of hydrogen gas? If you people can recall that chapter, which I have taught you in the earlier videos, it has been told over there that hydrogen is a gas which is popping in the light, its splinter. So you will write down the test like this: bring the lighted splinter near the test tube having hydrogen gas, and then the observation will be the gas will pop in the flame. Okay, so this is how we are going to write down the test. Okay, so in the same way, you can say this thing that more volume of hydrogen gas is produced in case of HCl, and lesser volume of hydrogen gas is produced in case of ethanoic acid. Then you can say this thing that ethanoic acid is a weaker acid as compared to this inorganic acid HCl. So this is how we are going to wrap up our results. This is how we can tell the examiner that this acid is a stronger acid or that acid is a weaker acid. Okay, I am now on the next page, and I'm now going to draw a flow chart so that you people may have an idea how to track about the reactions of these acids. Guys, these acids have approximately the same types of the reaction, exactly just like that of the inorganic acids, but one added reaction is there as well, and that is called as the reaction of these acids with alcohols to make esters. So right now I'm going to make this. Okay, so I am going to make this. Okay, so this is how it is. Okay, and this is one of the product. Okay, okay, and there is another product over there. Done, and there is a third product there. All right, and there is one more here. All right, and there is one more here. Okay, so we can say this thing that in this case it is like this. All right, okay, this is this, this is this, and this is this, and this is this. Okay, all right, okay, let me write down the stuff. Okay, so that you people may have a clear idea. So here I'm writing carboxylic acids, carboxylic acids. Okay, so it means that we are writing about the reactions of the carboxylic acids, we are writing about the reactions of the organic acids with this. Okay, let's see what is the reaction here. So when they are reacting with metal, okay, so they are going to produce metal salt. plus hydrogen gas, plus hydrogen gas. So when it is going to react with metal hydroxide, it is going to react metal hydroxide and going to give you metal salt plus water. Okay. So when it is going to react with metal hydroxide, metal oxide this time. Okay, hydroxide is done, so metal oxide. As a result, it is also going to give you metal salt plus water here. Okay, and then there is another result there, and that is a reaction of carboxylic acids with metal carbonate, and then we are going to make the product metal salt, and along with the metal salt, we are going to get carbon dioxide and water there. One test is with alcohol, and that is going to give you ester along with water as well. And there is one test which is left, and that is called result with ammonia. Okay, so here I'm writing this. And what is the way to give you this? Look at here right now. It is going to react with ammonia, and as a result, ammonium salt. What is the product? Ammonium salt only. Okay, so this is the flowchart diagram, which is just telling you that this is how the different types of the reactions of the carboxylic acids are going to happen. I will focus more on this. No doubt, I will write down the remaining five as like 2 to 3 examples for each of them, so that people may have a perfect idea, so that you people may have a clear concept about writing the reactions of the carboxylic acids. Guys, it is really very important to pay attention to focus on the reactions very clearly, very appropriately. Otherwise, the things will be remain in the problem as far as you people are not going to make a practice related to this. The things will be remain in a confused state. My advice, my suggestion to all of you will be remain this, that it is important to do the as much past papers as possible, because in this way the things can become improved, things can become clearer to all of you. All the best to all of you. In the next video, I am going to solve the past papers and related to this, and I'm going to solve the chemical reactions related to that. Okay, just take care of yourself.